Welcome to another deep dive. And today we're going to be tackling a topic that you specifically asked us to investigate,
Oh, wow.
Brownian motion.
Very cool.
And we actually got a really interesting mix of materials for this one.
Okay.
It's not just scientific explanations. We've
Yeah.
got some historical accounts. We even have some interactive simulations to play with.
Oh, that's awesome.
Yeah, it should be pretty fun.
Yeah, Brownian motion is such a great example of how, something that seems so random at the microscopic level
Yeah.
can actually have huge effects in, the world that we see.
Right.
Yeah.
Okay, so before we get too far ahead of ourselves,
Yeah.
let's start with the basics.
Okay.
What exactly is Brownian motion?
Yeah.
Our material defines it as the random movement of particles suspended in a fluid.
Okay.
And this movement is caused by collisions with the faster-moving molecules of the fluid itself.
Right. Yeah. And this is something that puzzled scientists for a long time.
Really?
Yeah, they observed, pollen grains in water, for example, just kind of like jiggling and dancing around seemingly at random.
I can see how that would be.
Yeah, and they couldn't figure out what was causing it.
Yeah, it's not like these tiny things have little motors or anything.
Right, exactly. And that's where Einstein comes in.
Oh, of course, Einstein.
Yeah. In
Right.
1905, he published this paper that actually explained what was going on.
Okay.
And he proposed that these particles, like the pollen grains,
Yeah.
were constantly being bombarded by way smaller invisible molecules of the water surrounding them.
So it's like a mosh pit, but microscopic.
Yeah, exactly. Imagine these bigger particles getting jostled around by a ton of tiny energetic molecules.
Okay, I can kind of picture that.
Yeah, and each time they collide, it changes the direction of the particle.
Right.
And since these collisions are happening constantly and randomly, the particle ends up taking this crazy, seemingly random path.
That makes sense, I guess. But how did Einstein prove this? It's not like he could actually watch these molecules colliding.
Right, he couldn't see them directly, but he was really clever and used math and observation.
Okay.
So he realized that if his idea was true, there would be a specific connection between the size of the particles, the temperature, and how far they traveled on average.
Oh, so he came up with a formula to predict how they would behave based on this idea of molecular collisions.
Exactly.
Wow.
And then people did experiments and they fit perfectly.
No way.
Yeah, it was huge because it actually helped prove that atoms and molecules existed.
Oh, wow. So this wasn't just explaining Brownian motion. It was helping to prove the existence of atoms themselves.
Right, because back then it was still kind of debated,
That's amazing.
Yeah, really groundbreaking.
It seems like every step of the way with this Brownian motion is full of surprises.
Yeah.
The way it was discovered, how it was explained, even
Oh.
how it changed how we see the world.
Yeah, definitely.
And speaking of surprises, I see we have some interactive simulations to check out.
Oh, yeah.
Maybe we can actually see this molecular mosh pit in action.
Yeah, for sure. These simulations are awesome for getting a feel for how it works.
Okay.
You can see the particles moving around.
All right, let's see what we've got.
And even change some of the variables to see what happens.
Well, this one is really cool. Just a bunch of particles bouncing around randomly.
Yeah.
It's kind of hypnotic to watch.
It really shows you how much is happening in a liquid, even if it looks still.
Right.
Yeah.
Makes you wonder if this is going on all the time. What kind of effect does it have on everything around us?
Oh, that's a great question.
I mean, these are tiny particles, but it's got to add up to something, right?
Right. And that actually brings us to one of the biggest results of Brownian motion,
Okay, what's that?
diffusion.
Diffusion. Is that like when you spray perfume and eventually you can smell it everywhere?
Yeah, that's a perfect example.
Okay,
So diffusion is basically the process of particles spreading out in a fluid.
okay.
And they go from areas where there are a lot of them to areas where there are less.
So how does Brownian motion fit into that?
Well, think about those perfume molecules you mentioned.
Okay.
They're constantly getting bumped around by the air molecules.
Yeah.
And that random motion causes them to spread out over time until they fill the whole room.
So Brownian motion is the engine behind diffusion.
Exactly. Without those random bumps, diffusion would be super slow.
Right.
It's those little chaotic movements that let particles mix and spread out so well.
That's amazing. And this must be happening all the time in so many different ways.
Yeah, you're totally right.
Not just with perfume, but with everything.
Exactly. It's essential for life.
Really?
Yeah, think about how oxygen gets from your lungs to your blood,
Oh, okay.
or how nutrients spread through a plant.
Yeah.
It's all driven by Brownian motion and diffusion.
This is blowing my mind. This random dance of particles is responsible for some of those basic processes in nature.
I know, right?
That's why I love these deep dives. You never know what you're going to learn.
Totally. And we've only just started. There's so much more to explore about Brownian motion and what it means.
Well, I'm ready for it. What else can you tell me about this incredible world?
All right, let's dive in.
Okay, so we've talked about how Brownian motion helps explain, like, how perfume spreads or how oxygen gets into our blood.
Right.
But are there other areas where this random movement has a big impact?
You know, you might be surprised to learn that Brownian motion is super important in, like, shaping the materials that make up our world.
Really?
Yeah.
I never thought about it that way, but I guess when you think about it at the molecular level, it makes sense.
Exactly. Like, imagine you're designing a new plastic.
Okay.
You want it to be strong, but also flexible.
Right, so how does Brownian motion play into that?
Well, the flexibility of a material depends on how easy it is for the molecules to move past each other.
Okay.
And guess what? That movement is affected by Brownian motion.
Oh, so by understanding how those molecules are jiggling and bumping, scientists can actually engineer materials with specific properties.
Yeah, exactly. They can, like, tweak the chemical structure or add different stuff to either help or block the movement of the molecules.
That's so cool. It's like they're choreographing a molecular dance to make the materials we need.
Haha. Yeah, that's a great way to put it.
And this applies to all sorts of materials, right?
Oh, yeah, definitely from, like, fancy alloys used in airplanes to the clothes we wear.
Wow. So it's not just about understanding Brownian motion, it's about using that knowledge to make new things.
Exactly. That's where it gets really powerful. It gives us a way to predict and control how materials will act at, like, the most basic level.
This is making me think about those simulations again.
Yeah,
They're not just pretty pictures, they're actually important tools.
for sure. Scientists and engineers use simulations all the time to see how Brownian motion will affect different materials.
Uh-huh.
They can test different designs and see how changing certain things will impact the final product.
So they could design like a lighter but stronger airplane wing
Exactly.
or a more efficient way to deliver medicine.
Yeah, it's all about using those tiny random movements to get the results you want.
It's like we've cracked the code of the universe,
Uh-huh.
and now we can rewrite it.
You got it. And it shows that sometimes the biggest discoveries come from looking at the most ordinary stuff.
Right. Who would have thought that the random jiggling of particles could be the key to so much innovation?
It's true. And it's not even just about practical stuff.
Oh, what else?
Understanding Brownian motion also helps us understand how the world works at a really basic level.
Okay, yeah, that makes sense.
Yeah.
It's like a reminder that even in the most complicated systems, there are these simple rules at play.
Yeah, exactly. And it shows how connected everything is.
That
How things happening at the smallest level can affect everything
Oh, I
else.
see.
Yeah.
Now, I remember you mentioned something before called fractional Brownian motion.
Oh, wait.
Is that connected to what we've been talking about?
Yeah, it is, but it's a little more complex.
Okay, how so?
So regular Brownian motion is all about completely random movement. But fractional Brownian motion says that in some systems, there might be some kind of pattern or memory in how the particles move.
Okay, can you give me an example?
Sure, think about the stock market.
Right.
The price of a stock goes up and down over time.
Yeah,
And while there's definitely some randomness, there's also, like, underlying trends.
right.
So it's not totally random like those particles we saw in the simulations.
I see.
There's some memory or persistence in how the price changes, and that can be modeled using fractional Brownian motion.
So even in the crazy world of finance, there's some Brownian motion at play.
Yeah, it's everywhere.
Wow.
From how molecules move to traffic in a city, fractional Brownian motion is a really useful tool for understanding complex systems.
This is making me think about all the stuff that's happening that we can't even see,
Yeah.
and how even in all that chaos, there are these basic principles controlling it all.
It's pretty amazing, isn't it?
It is. Okay, I think my brain is getting a little full here. But before we go on, can we just quickly recap what we've learned so far?
Sure. So we started by defining Brownian motion and looking at its history.
Yeah.
Then we talked about how this random movement actually drives diffusion, which is super important for a ton of processes in nature.
Right, and we saw how scientists are using their knowledge of Brownian motion to create new materials, invent new technologies, and even understand things like financial markets.
Exactly. And we even touched on fractional Brownian motion, which helps us model systems where there's both randomness and order.
Okay. That's a lot to take in,
Yeah,
but it's all so interesting.
I know. It's really cool stuff.
I'm ready to keep going, though.
Yeah.
What else can you tell me about this amazing world of Brownian motion?
All right, let's get into it.
So we've covered like what Brownian motion is and why it matters.
Right.
But what about the how?
The how.
Yeah, like how do scientists actually study something that's happening at such a small scale?
That's a really good question. It's not like we can just use a microscope and watch the molecules bouncing around.
Right. It seems like it would be so hard to track something so tiny and moving so fast.
Yeah, exactly. It takes some clever thinking and a lot of ingenuity.
Okay, so what do they do?
Well, instead of trying to see the individual molecules directly,
Yeah.
scientists usually focus on the effects of their motion.
So it's like they're detectives looking for clues.
Yeah, exactly. Like, one common method is to track the movement of a larger particle
Okay.
that's being jostled around by those tiny invisible ones.
So they watch a bigger particle dancing around and use that to figure out what the smaller ones are doing.
Exactly. They can study its path over time, measure how far it travels, and use that data to understand the properties of the molecules around it.
That's pretty amazing. It's like using math to decode the invisible world.
Right, and they've come up with some really sophisticated tools to do this.
Like what?
Well, there's one technique called dynamic light scattering.
Okay.
It involves shining a laser through a sample and looking at how the light is scattered by the particles that are undergoing Brownian motion.
Oh, wow. So they're using light to reveal the secrets of these tiny molecules.
Exactly. And by studying the pattern of the scattered light,
Yeah.
scientists can figure out the size and shape of the particles and even how fast they're moving.
That's incredible. It's like a whole new way of seeing the world.
Yeah, it really is.
And this isn't just for like basic science research, right?
Nope, not at all. It's got tons of applications in areas like medicine materials, science, and even environmental monitoring.
Can you give me some examples?
Sure. So in medicine dynamic, light scattering is used to study how proteins and other biological molecules behave,
Oh, wow.
which can help researchers figure out how diseases work and design new drugs.
So they're studying the building blocks of life with this technique.
Exactly. And in materials science, it's used to understand nanoparticles.
Nanoparticles.
Yeah, they're these super tiny particles with unique properties that are being used in all sorts of new technologies.
So those tiny particles being bounced around by Brownian motion are actually being used to create new technologies.
Yep. It just goes to show how understanding a basic principle of nature can lead to real-world innovation.
That's wild. Okay, so we've got new ways to see these tiny particles and new ways to use them.
Right.
Are there any other new technologies being developed based on what we know about Brownian motion?
Oh, yeah, definitely. One really cool area is in developing super sensitive sensors.
Sensors.
Yeah?
That use these random movements. How does that work?
Okay, so picture this.
Right.
You've got a tiny cantilever, like a miniature diving board,
Okay, I can picture that.
and it has a special molecule called a receptor attached to it.
Okay.
Now, when a specific target molecule, like a virus or a pollutant, comes along and binds to that receptor,
Yeah.
it changes the cantilever's mass just a little bit.
Okay, I'm following so far.
Yeah.
But where does Brownian motion fit in?
Well, that cantilever is constantly being hit by all the molecules around it.
Yeah.
And that makes it vibrate at a specific frequency.
So it's like a tiny little drum.
Exactly. And when that target molecule attaches to the receptor, it changes the drumming frequency just a tiny bit.
Oh, I get it.
Yeah.
And that change in frequency tells you that the target molecule is there.
Exactly. It's unbelievably sensitive. These sensors can detect like a single virus or a tiny amount of pollution in the air.
That's insane.
Ah,
So these random movements are being used to make a super sensitive alarm system.
you got it. And that's just one example of the amazing things we can do because we understand Brownian motion.
I think we can officially say we've reached the bottom of this deep dive.
Uh-huh. Yeah, I think so.
We explored what Brownian motion is, why it matters, and even how scientists study it.
We covered a lot of ground.
We went from its history to its cutting-edge uses. It's been a pretty amazing journey.
It really has. And it just shows how powerful scientific curiosity can be.
Totally.
Like by studying something that seems ordinary,
Yeah.
we can learn these incredible secrets about how the universe works and create technologies that can change the world.
I totally agree. Who knew that these tiny jiggling particles could be so fascinating and important?
It's a great reminder that there's always something new to discover,
For sure.
even in things we think we already understand.
Well said. Thanks for joining me on this deep dive into the world of Brownian motion. It's been awesome exploring this with you.
It's been my pleasure. Until next time, keep exploring and keep asking questions. All